Hey everyone, today we're looking at lesson 13, which starts us into a new section of unit 6. So we just finished working with equations. Now we're going to be talking today about something called inequalities, and that hopefully sounds familiar to you. I know as we go along and we talk about more of these symbols with inequalities, I'm sure you'll recognize what we're talking about. So to begin, we have a number line that shows values of x that make the inequality x is greater than 1 true. And that's what we're talking about today for inequalities. We're talking about these symbols greater than and less than and how they're representing more than just one number now. In an equation, there can only be one answer for x. But here, in an inequality, it's giving us a variety of answers. So, looking here at the number line, it says shows us inequalities of x greater than 1. And you can see how the arrow is going to numbers larger than 1 on the number line. And it's continuing on because obviously there's a lot more answers to this inequality than just stopping at 5. That's going to continue. So it says select all the values for x from this list that make the inequality true. Well, we could certainly say that 3 is greater than 1. Negative 3 is not. That's over here on this side of the negative side of the number line. 1 is an interesting question. Is 1 greater than 1? I think hopefully you would all say no, that they're the same. So that would not make that statement true. But certainly 700 is. And if we go just larger than 1, 5/100ths more than 1, that would make that statement true as well. Name two more values for x that are solutions to the inequality. Go ahead and type those into the comments. Okay, for our next activity, it says the sign next to a roller coaster at an amusement park says you must be at least 60 inches tall to ride. Noah is happy to know that he is tall enough to ride. Noah is x inches tall. Which of the following can be true? All right, we had part of this cut off. This first inequality is x is greater than 60. Then we have x is equal to 60 or x is less than 60. All right, well, which of the following can be true? If you must be at least 60 inches tall to ride, then Noah would need to either equal 60 inches, because that would mean he could ride, but he could also be taller than 60 inches, and this would be a way to represent that as well. I think both of these expressions tell us what Noah's height could possibly be. If we look at the next part, Noah's friend is 2 inches shorter than Noah. Can you tell if Noah's friend is tall enough to go on the ride? Well, in this case, we can't really tell because if Noah equals 60 inches tall, if he's exactly 60 inches tall and he can ride, that would mean that his friend would be too short. So if we had to answer this, can you tell if Noah's friend is tall enough to go on the ride? No, you can't. In a lot of cases, he would be able to ride. If Noah was 65 inches tall or 70 inches tall, then he'd be fine. But if he was very, very close to 60 inches, then his friend wouldn't be able to. List one possible height for Noah that means that his friend is tall enough to go on the ride, and another that means his friend is too short to go on the ride. So going back to what we just talked about, if Noah, let's see, so if his friend has to be 60 inches in order to ride, then he would be, then Noah would need to be at least 2 inches taller than his friend. So if Noah was 62 inches, so Noah is 62, then his friend can ride because his friend would be 60 inches tall. But if Noah was, say, 61 inches, then his friend is not going to be able to ride because his friend would be 59 inches tall and that would be too short to go on the ride. Here's where we're going to use a number line to kind of represent all the possible heights of Noah here. So on a number line, show all the possible heights Noah's friend could be. So keep in mind, if Noah was exactly 60 inches tall, that would make his friend 2 inches shorter, 58 inches tall. So 58 is a possible height for his friend, so is 59, 60, and then on up, really through the rest of the number line. Noah's friend could be 68 inches tall, we don't know. Now what we need to think too is not just by the whole inch, because people's heights could be anywhere in between whole inches as well. So he could be 58.5, 58.3 inches tall, anywhere in here. And instead of just making dots at the whole inch marks, what we'd want is a line that would show an inclusion of everything in between those whole inch numbers. So we'll start at 58. Now, there is something on a number line that's going to show us whether or not where we're starting on the number line is included in the information or is not included in the information. So there's two things. We have open circles, which are open circles, and we have closed circles, which are closed circles, filled in circles. Now, if we were to put a closed circle here at 58, we're saying that we are including this as an answer to what Noah's friend's height could be. And we did say Noah's friend could be 58 inches tall. So we're going to put a circle there that includes 58 and then an arrow including all heights greater than that for Noah's friend. Okay, we do want to include 58. If we put that empty circle there, we couldn't have a height of 58 for his friend, and that's not true. And then lastly, Noah's friend is y inches tall. Use y and any of the symbols to express his height. So Noah's friend is y inches tall, and we want to express his height as, well, if we can only use these three, it's a little tricky, because if we say Noah's friend's height has to be greater than 58, that's almost true, but we're leaving out the fact that he could be exactly 58 inches tall. We also have to include that his height, y, could equal 58. So we need to also include that y equals 58 as a possibility. Now there is a symbol that combines both of these together. And if we were to put y is greater than or equal to, messing it up here. All right, see how it looks like an equal sign, but we still have our greater than sign. So we're showing both of those possibilities. We're saying that Noah's friend's age could be bigger or equal to 58 inches. And that would be the best way to represent that situation. Let's move on to the back. So turn in your packet to the back side. This table, unfortunately, copied terribly. So if you would please fill in the information with me for what was blocked out here. So this would be 0, then 100, negative 100, and 25. And these are all values of x. That's what's being represented along the top of the table. Then we have 4 different inequalities written down the sides. The first one is x is greater than or equal to 25. I'm going to go ahead and fill in the rest of these real quick so that we have this information. So the next one is 100 is less than 4x Then we have negative 3x is greater than negative 75. And finally, 10 is greater than or equal to 35 minus x. Those would be the 4 inequalities that we're going to complete the table for. All right, so the directions tell us to use the table, shows 4 inequalities, 4 possible values of x, decide whether each value makes each inequality true, and complete the table with true or false. Now, let's look at this first one. So it says x must be less than or equal to 25. And our first possible value for x is 0. If you're having trouble picturing this, try rewriting it. So if I were to write my possible value for x, which is 0, if 0 is less than or equal to 25, that's the question I'm trying to answer here. And yes, 0 is less than 25. This is a true statement. Okay? I'm going to do the same for 100 now. So I'm going to ask, is 100 less than or equal to 25? And in this case, no, 100 is not less than 25. That's a false statement. That's the idea that we're going to continue. We're going to look at a couple more together, and then I want you to complete the rest of the table before moving on. Let's jump down to the next inequality. So now we have 100 and the variable switches to the other side of the inequality. That's okay, there's nothing wrong, just like when we switch or reverse an equation. So now we're saying 100 is less than 4x's. Well, if x is 0 here, we use a different color, and we say 100 is less than 4x's, that's 4 zeros. 4 times 0 is still 0, and is what we're trying to answer here, is 100 less than 0? No, it's not. That's a false outcome for what x could equal. If we carry it over to 100, 100 is less than 4x's or 400s, and now it's a true statement. Let's look at the next value, the next inequality. So negative 3x is our term. That's negative 3 times 0, so that's still going to be 0 is greater than negative 75. That's true. 0 is greater than any negative number. But let's try it with 100. So negative 3x, negative 3 times 100 is negative 300. Is that greater than negative 75? Well, with how negative numbers work, this is more negative quantities, so we're getting further negative, we're getting less value. So this is not a true statement, it would be false. And the same idea is going to carry for the last inequality here, but we have 10 is greater than or equal to 35 minus 0, 35 minus x. That's 35. That's going to be a false statement. 10 is not greater than 35. And if we look at it for 100, we would take 10 greater than or equal to, now we need to do a little calculating here, 35 minus 100. That's going to get us into a negative value. Now, think about this. I could calculate this, but I don't have to know exactly what the value is. If I'm taking 100 away from 35, it's going to be negative something, and a negative number is definitely going to be smaller than 10. 10 is going to be bigger than any negative number I come up with here. So even without calculating, I can see that's a true statement. Now, would you go ahead and fill in the columns for the possible values of x as negative 100 and 25? Okay, hopefully what you found, let me go ahead and fill these in for you, is the values for negative 100 are true, false, true, false. And then if x was 25, it would be true, false, false, true. All right. Now, hopefully, again, you can see how important these rational number rules are, because even in this inequality situation, we're dealing with negative amounts. We're multiplying two negative numbers here in this inequality. We're multiplying a negative and a positive in this inequality. Keep in mind how important those rules are. Keep them fresh in your mind. And let's go on to one of the final parts here. So here's an inequality. Negative 2x is greater than 10. List some values for x that would make this inequality true. All right. We need to make the left side of this inequality larger than 10 for it to be a true statement. So I'm going to start using some of my number understanding to narrow this down. Well, if I were to put a positive number here, like let's say number 1, negative 2 times 1. So let me write down my thinking here for you. Negative 2 times 1. That equals negative 2. And negative 2 is not greater than 10, so that doesn't work. Now what I'm going to try is I'm going to try a larger positive number. Let's do negative 2 times 100, and I'm just picking easy numbers that I can multiply in my head. That's negative 200, which is still not bigger than 10, so that's not working. It doesn't seem like using a positive number here for x is going to work out well. It's just getting me further negative, which is less and less value. So now what? I just have to reverse this and try negative numbers. So let's do negative 2 times negative 1. That's going to equal positive 2. Okay. Positive 2 isn't bigger than 10, but we're definitely getting close. We're going in the right direction. So I might just need another negative number, a more negative number. Let's do negative 2 times negative 10. That's 20. And 20 is bigger than 10. So that one checks out. That works. So list some possible values for x that make this inequality true. Well, we just found negative 10. My hypothesis is the larger the negative number that I'm using, the better this is going to work. So let's do negative 100. That equals 200, and 200 is bigger than 10, so that one works as well. Now I can just pick some values and be pretty confident that they're going to work. So I could say negative 1,000, I could say negative 11, all sorts of choices here. It doesn't specify how many examples we need to give. Let's just leave it with 2. Now, how are the solutions to this inequality different from the solutions to this inequality? They look almost identical. Let's find the difference here. It's right here in the inequality sign. This first one is greater than or equal to. This one is just greater than. So in this first one, our answer can equal 10. Let's think of what that would be. So it's negative 2x equals 10. What would x be here? It would be negative 5. So in this case, x equals negative 5. That is a possible choice with this inequality here. But if I put negative 5 into this inequality, the one that we were just working with, negative 2 times negative 5 is 10, but 10 is not greater than 10. It wouldn't be true here, but it would be true here. So very small detail, but it's really important to see the difference in what those symbols can make. Now, I would like you to go through here, take a look at this table just to end the lesson. It labels the name of each of the inequalities that we're using. It gives a description down here. I want you to fill in the symbol to represent that, and then check back with your answers. All right, hopefully you got for less than this symbol here. Okay, a lot of people remember it because it is in the same direction and almost the same shape as a capital L for less than. Greater than would be going the other direction. Then less than or equal to adds that bar below it, which gives us what looks like an equal sign as well. Greater than or equal to, and not equal, one that we don't use often, looks like that. We're crossing through that equal sign, saying it's not equal. All right. Now, please check out the Lesson 13 practice problems. Don't forget that tonight you have another iReady lesson due, and you can do an extra for a bonus. I'll be checking that in the morning and adding it to your grade, and I will be on Zoom for any questions that you have. Have a great day.